kids, welcome back. So let's move on with the next topic, which is time. Question 1 says, here is a clock face showing a digital time. So here, as you can see, this is in the 24-hour format, and the times that are given below are in the 12-hour format. So what you're supposed to do is to match it, and when you see that this is 23, which means that in the 24-hour clock it is after 13 hours, this means that it's in the afternoon. Therefore, what we do is we cross out the AM answers because they're wrong, and then we are left with 3 answers. So 23 is actually 11 p.m. and therefore we select this as our answer. 2 p.m. is 14 hours because we start from 13 hours being 1 p.m., 14 hours being 2 p.m., 15 hours being 3 p.m. and so on. So this is why 23 hours is 11 p.m. You can keep going and see that you will get this value. So here 3 p.m. is then 15 hours. So because it's 23 hours, your answer is 11:23 p.m. Great. So now let's move on to the next question. Here is a part of a train timetable. 6 train travels from Newcastle to London. We have 6 different trains, A, B, C, D, E, F. Some of these trains take less than 3 hours to travel from Newcastle to London. Write the letters of these trains. So you need to check the time difference between Newcastle and London. So 10:35, 11:35, 12:35, 1:35, that would be 3 hours. But in this case, it reaches London at 1:43, which is after 1:35. Therefore, this is greater than 3 hours. Likewise, you need to check this for each of these trains. So 10:59, 11:59, 12:59, 1:59. This is smaller than 1:59. So B is less than 3 hours. And then from 11:30, 12:30, 1:30, 2:30. This is greater than 2:30. And then from 12:25, 1:25, 2:25, 3:25. This is 3:44. So again greater, which means that we need to check the last 2 trains. Okay, so 12:57 is 1:57, 2:57 and 3:57. This is 3:51, less than 3:57. So this is right. And then 1:30, 2:30, 3:30, 4:30. This is bigger than 4:30. So therefore, we have 2 trains that take less than 3 hours, train B and train E. Pretty simple, right? The next question says, calculate the number of minutes taken by train D to travel from Newcastle to London. So these are the values of train D. In order to check the time duration, you need to subtract the starting time from the arrival time. So that would mean we have 15:44 minus 12:25. So here we subtract the whole minutes. We don't check 4 minus 5 and 4 minus 2. Rather, we check 44 minus 25. So we have 9 and 1. So 19 minutes. And then 15 minus 12 is 3. So the time duration here is 3 hours and 19 minutes. But the question is asking for the answer in minutes completely. So we first need to convert this 3 hours into minutes as well. In order to do this, 1 hour is equal to 60 minutes. So we need to multiply the hours by 60 in order to find the minutes. So 3 hours would be then multiplied by 60, which is 6 times 3 is 18, and we have the 0, so 180 minutes. Don't forget that we need to add this minutes of the 3 hours to the 19 minutes that we have over here. And once we add these two, we have our answer. So 180 minutes from the 3 hours and 19 minutes from the minutes will add up to 199 minutes. So this is our answer. Just going to write this for reference to how we got 199 minutes. Now let's move on to the next topic, shapes. So question 1 says, here are some shapes A, B, C, D, and E, and we are supposed to classify this into polygon and not a polygon. So what is a polygon? A polygon is basically a closed 2D shape that is made of straight lines. So this shape over here is not closed, it's open. And this shape over here has a curved line, which means that B and D are not polygons. So we would classify this over here. And then, like I just told you, a polygon is a 2D shape, a closed 2D shape which has straight lines. So here we have closed 2D shape with straight lines, same over here and over here. So A is already done for you. So we are left with C and E. So we would put the letters in this column. Great. Next, let's look at this 3D shape. The net of the 3D shape. So what you can look at this net and decide, or rather conclude, is that these are made up of square faces. So there's square faces and there's 6 of them. So there's 6 square faces, and if you remember 3D shapes, a cube is what has 6 square faces. So here I drew a rough cube, and we have all of them are square. We have one face on top, the other face in the bottom, and then we have 3, 4, 5, and 6. 4 faces right around. So altogether it's 6 faces, which means that this 2D shape, 3D shape is a cube. Pretty easy, right? So let's move on to the next question, question number 3. Here are 6 shapes on a grid, A, B, C, D, E, F. Write the letters of the 2 shapes which are pentagons. So what is a pentagon? A pentagon is a shape that has 5 sides. If you remember, you know that we have shapes from 3 sides: 4, 5, 6, 7, 8, 9, 10. So this is a triangle. These are quadrilaterals. Please don't write words like this. I just have no option. Just write them in a straight line. And this is a pentagon, a hexagon, heptagon, octagon, a nonagon, and a decagon. So these two are asked less, but all of the others you are expected to know the names very well. So pentagon is a shape with 5 sides. Therefore, we are going to count the sides. Here we have 1, 2, 3, 4. So this is a quadrilateral. 1, 2, 3, 4, 5, 6. This is a hexagon. 1, 2, 3, 4, 5, 6. Another hexagon. 1, 2, 3, 4. A quadrilateral again. 1, 2, 3, 4, 5. Here we go, a pentagon. And 1, 2, 3, 4, 5. So this is another pentagon. So our answers are D and E. Great. The next question is asking you to write the letters of the two shapes which contain at least one pair of perpendicular lines. So let me take you back to perpendicular lines and parallel lines. So parallel lines are lines that do not meet when we extend them in any direction. They will never ever meet. So these two are parallel lines. And then we have perpendicular lines, which are lines that meet at a 90-degree angle. So anything that looks like this or like this, these are two perpendicular lines. So if we look at the shapes, the question says two shapes which contain at least one pair of perpendicular lines. So we have over here a right angle, so that's one. And then we also have right angle over here. No, that looks slightly bigger than a right angle. Oh, we have a right angle over here. So you can use your ruler and place it like this on the edge, and then that is how you see that this is actually bigger than a right angle, whereas a ruler has a straight edge, so this should perfectly fit into a shape that has a right angle in the corner. Right, so no right angle over here. So our shapes that have a right angle and therefore perpendicular lines is B and D. The next topic is rounding off. So question number 1 says round 2648 to the nearest hundred. So 2648. 6 is the number in the hundreds place, so we would draw a dotted line after that, and we check the number on the right side of the dotted line. So we check if 4 is less than 5 or greater than 5. And greater than 5 includes the number 5. So here 4 is less than 5, which means that we are not going to add 1 to 6. We just keep it as it is. So that's 2, 6. And then we need to change the two numbers that are after the dotted lines into zeros. So 2648 is closer to 2600 than 2700. Next, we need to round off 3568 to the nearest 10. So here the digit in the tens place is 6. We draw a dotted line after that and we check the number on the right side of it. So in this case it's 8. So if the number we check is 5 or bigger than 5, we need to add 1 to the 10. So here then it's 357 before the dotted line. And then remember we need to put a 0 to replace the numbers after the dotted line. So in this case we add 1 0. So it's basically saying that 68 is closer to 70 than 60. Right. So next let's draw a line to match each number to its value when it's rounded off to the nearest 1000. And in order to do this, these are the numbers in the 1000 places. So I will draw a dotted line after that. And here it's 5, so we add 1. So it's 216,000. Here it's 5, so we add 1. So it's 215,000. Here it's 4, so we do not add anything. We leave it as it is. So here it's 216,000. And then here it's 0. So it's smaller than 5, so we don't do anything. So it's 215,000. So here you can see that just because there's 4 numbers on each side doesn't mean that each of it needs to, link to another one, right? So this could be sort of a trick question. Don't get fooled by it. Just look at your numbers and round it off properly and then match to the answer. Right. So next, question 3 says, draw a ring around all of the numbers that equal 9 when rounded to the nearest whole number. So here the whole number is the number before the decimal point, because after that it's like fractions. So I'm gonna draw my dotted lines over here. And we check the number after it. So it's 0. We don't add anything. So it's 8. Here it's 8. So it's bigger than 5. We add 1. So it's 9. So we continue this the same way. Here it's 4. We don't add anything. It's 9. Here it's 2. We don't add anything. It's 8. Here it's 5. We add 1. So it's 10. Here it's 5, we add 1, so it's 9. So the question wants you to draw a ring around the ones that equal 9. So we have this, and this, and this. And this is how we do this question. We have one more rounding off. So here again we need to round it off to the nearest whole number. 7.7 and 10.25. So I will do this individually. Nearest whole number means we draw a dotted line on the decimal point, check the number after that, If it's 5 or bigger than 5, we add 1. So 7 plus 1 is 8. The answer here is 8. And then let's do this. We put a dotted line over here on the decimal because it's round off to the nearest whole number once again. We check the digit after that. It's 2. It's smaller than 5. So we are not going to add anything over here. We keep it as it is. So our answer is 10. An important thing to remember here is we do not add zeros after the dotted line when we round off to the nearest whole number or the nearest first or second decimal point. Right? So whenever the dotted line is either on the decimal or after, so let's say somewhere here, right? Then we do not add zeros afterwards. We just stop right where we have the dotted lines. Great. So next we need to move on to the topic fractions. The first question says shade 1/5 of this diagram, but here we have 10 parts, so we can't just shade only one of it. That will be 1/10, 1 over 10. So instead we would then divide this into 5 parts. This is 1, 2, 3, 4, 5, and we shade only one of these 5 parts. So this is the answer for shade 1/5 of this diagram. Next, we are asked to simplify. So for this, once again, it's very helpful if you know the times table, multiplication table. 6 over 12, both of these are in the 6 times table. 6 is 6 times 1 and 12 is 6 times 2. So our answer is 1 over 2 or half. So we do the same thing to the next one. 12 and 15, they are both in the 3 times table. So here 12 is 3 times 4 and 15 is 3 times 5. So our answer is 4 over 5, 4/5. Right. So I'm going to do one more fraction. Sorry about that. Sometimes we will have a fraction that's much bigger. So maybe something like 32 over 54. Or let's, 54. We'll make it 56. So if we are to simplify this, right, here we can see that these are both even numbers. So we can divide both of these by 2, right? So 32 divided by 2 is 16 and 56 divided by 2 is 28. And then we have our answer, but if you look closely, this is not in the simplest form because these are still both even numbers, which means we can simplify it even further. So here then, in this case actually, we can say that these are both in the 4 times table, right? So we can, this is 4 times 4. And this is 4 times 7, right? So we are left with the simplest form of this fraction, which is 4/7. Right. So that was just a bit of extended information from the paper, which I think is important. Question number 3 says, draw a ring around the 2 fractions which are equivalent. So in order to answer this, um, we need to identify the fractions that have similar denominators. So for instance, these are both in the 5 times table, right? So since these are in the 5 times table, I can make this 25. And how do I make 525? I multiply it by 5. And whatever I do to the denominator, I need to do to the numerator as well. So 3 times 5 is 15. And you can see that it's actually the same fraction, right? So which means that these two are equivalent. So I chose the correct two fractions by chance. So I will draw a ring around it, but I will also show you what choosing two other fractions would have looked like. Here, these are again two denominators that are in the same times table. 12 can be uh, converted to 24 by multiplying by 2. 12 times 2 is 24. Whatever we do to the denominator, we need to do to the numerator. So 6 times 2 is 12. And here we have 12 over 24, which is not the same as 10 over 24, which means that these are not equivalent. So this is how you would answer this question. You would look around and try and figure out which two fractions are equivalent. Great. So now let's move on to the next page. We have a fraction question here once again, which requires finding equivalent fractions. Because when we get fractions like this with the same denominator, right, and we are asked to order this from smallest to largest, we can easily compare this because it's the same denominator. So we know that 2 is the smallest, so it's 2 over 5, 3 over 5, and 4 over 5. However, if you look at these fractions, you can see that their denominators are not the same. We have 2, 16, 4, and 8. So what we would do here is we would try to make the denominator the same. And we can do this. We can make the smallest the small denominators. We can convert it into the largest denominator here, which is 16, right? So what we would do is then to convert this, we multiply 2 by 8. So the same thing over here by 8. 1 times 8 is 8. 2 times 8 is 16. So half is equivalent to 8 over 16. And then we would do the same here. So to make 416, we need to multiply it by 4. Same thing to the numerator. 3 times 4 is 12. And 4 times 4 is 16. Then finally, we have 5 over 8. 8 can be converted to 16 by multiplying by 2. So same thing to the numerator. 5 times 2 is 10. So here our equivalent fraction is 10 over 16. Right. Now that we have all our fractions with 16 as their denominators, we can compare them. But remember, when we write the answer, we do not write the fraction that we came up with, the equivalent fraction, rather the original fraction that was given in the question. So in this case, we are supposed to order it from the largest to smallest. Be very careful with this because most of the times students are used to ordering it from smallest to largest. So here we have 8 over 16, 7 over 16, 12 over 16 and 10 over 16. So this is the largest. So I'm going to write 3 over 4 here. And then after that it's 10 over 16. So I'm going to write this 5 over 8. And then the next largest is 8 over 16. So I'm going to write the fraction that they had given us originally, half. And then finally we have the smallest fraction, which is 7 over 16. This case, this is what was given to us originally. So we write 7 over 16. So this is our answer. 3/4, 5/8, half, and 7 over 16. Right. So if you are unable to make each of the denominators the largest denominator like we did in this case, then you need to list down all of the denominators and find its lowest common multiple, and you would convert all the denominators to the lowest common multiple. That is not something I'm going to cover in this paper. Hopefully we can do it some other time. Great. So the last topic for this video is probability. Question 1 says a fair 6-sided dice is rolled once only. So we know what a dice is. The numbers are from 1 to 6, right? So 1, 2, 3, 4, 5, 6. These are our possibilities. We are supposed to write the likelihood of each of these events occurring. And we need to select these words, use one of the words below to describe the likelihood. A number 4 is rolled. So we have a total of 6 outcomes. And the chance that 4 is rolled is only 1 because 4 occurs only once. So 1 out of 6 chances is a pretty low chance. Therefore, the word we would use here is unlikely. Next, a number less than 20 is rolled. So all of these numbers are less than 20, which means whatever outcome we get will be less than 20. 6 out of 6. Sorry about that. So here we would say that this is certain. So the word we use here is certain. And the next one says an odd number is rolled. So what are our odd numbers? 1, 3, and 5. That's a chance of 3 out of 6. So 3 out of 6 is exactly half of the possible outcomes. And if this is the case, the word we use is even. So here we have an even chance of getting an odd number. And then we have a multiple of 10 is rolled. So the multiples of 10 are 10, 20, 30, so on. None of these are multiples of 10. So the chance here is 0 out of 6, which is impossible. So that's pretty much it. Then question number 2 says, what percentage of this shape is shaded? So percentage is a form of, writing probabilities. Sometimes we write it in the form of percentages. That's why I added it under this topic. To write the percentage, first we need to write the fraction. And then we need to convert it to a percentage. So we have 1, 2, 3, 4 that are shaded. out of a total of 5, 6, 7, 8, 9, 10. 4 over 10. This is our fraction. And in order to find the percentage, we multiply fractions by 100 to convert it to a percentage. And in this case, we would simplify this to make it easy. 10 times 1 is 10, and 10 times 10 is 100. We can always simplify a number that is down with a number that is up. So we are left with 4 times 10, 40. And in the bottom we have 1. So 40 over 1 is basically 40. Our answer here is 40%. Okay, so that's it for this video. We will discuss the rest of the topics hopefully in the next video.